All right, I've got a TI-84 Plus emulator here, and what I've done is into the y equals, I've typed in the function that I had there written on the page. So negative 0.2, that's the 1 divided by 5, times e to the x minus cosine x divided by 5 times the quantity, the integral from 0 to x of e to the cosine q minus q over 5 dq minus 5 times, now the 0.05 is the y0, and they're asking us to do this for different values of y0 between 0.5 and 1. And anyway, so there's the function. So the trick here is using the math int the integral function, which is function int in the math menu of the TI here. Okay. So in this math menu right here under math function int. Okay. I want to get out of this. Go back to the y equals. Okay. Anyway, notice this is an x cosine x, and over here it's cosine q minus q because one of them had a negative sign because you were dividing by it. Anyway, and these are q's because this is the dummy variable inside of the integral. Okay. The variable here is x. So anyway, when we draw the graph, the y equals. Draw the graph. Here we go. I'm plotting this from -1 to 20 or something like that on the x-axis, minus 10 to 10 on the y-axis. One of the things I see is that it's kind of got a little bit of a wiggle, but it's headed downhill. If I change that initial condition now, stop it. If it's, this is going to graph slowly because this calculation takes a long time, this integral. But I want to change now to another one. That was with 0.5. That's at one end of the spectrum. If I change that 0.5 to a 0.9, let's say to a 1 or 0.99, just go, whoops. What do I have to do? I have to insert times, there we go. And now look at the graph. And now what happens is it climbs, and you can see that for some values of y0, the graph will be trending downward, and for other values it'll be trending upward, and the question is, can you sort of find the transition value? And it's experimental evidence here. There's no algebra really that's going to be able to solve this for you. But yeah, there's some initial starting value that keeps this, this looks like a sine wave or cosine wave. It keeps it on the same level rather than going up or rather than going down. Okay. So anyway, there's the graph of an integral that you don't know how to do the integral. Your calculator can do it numerically.